In this video, the learner will use the ratio of the sides of an isosceles right triangle to solve for the missing lengths. Where does the right isosceles triangle come from? Well, first we start with a square, where we know all the sides are congruent and there are 4 right angles. When a diagonal is drawn in the square, we have cut the square into 2 right isosceles triangles. The right isosceles triangle is nicknamed 45, 45, 90 because they will always have these angle measures. We have 45 degrees, and then our right angle. Through our discovery lesson in class, we found out the ratio of the sides were x, x, and x root 2. We'll use this common ratio to help us solve for missing side lengths. The ratio of the sides is the same for all 45, 45, 90 triangles because all right isosceles triangles are similar. Because they will always have the same angles, it follows the AA theorem. So we can use the ratio that we found to solve for missing lengths. Every time we do a problem, I use a table to help me organize my thinking. So I use 45, 45, and 90 because those are my angles. And x, x, and x root 2 is my ratio pattern. Because across from each 45 is one of the legs. Across from the other 45-degree angle is the other leg, which are going to be congruent because it's isosceles. And then across from the right angle is our hypotenuse, or that x root 2 part of our pattern. So let's use that ratio pattern here to solve for the missing lengths in this triangle. Well, we know we're going to use our 45, 45, 90 pattern because we see a 45-degree angle here. That means automatically we know the ratio of the sides is x, x, and x root 2. Notice we're given the side across from one of the 45-degree angles. That means that we know one of our x's is 5, so the other x has to be 5. Therefore, we can plug in the x for this x and get 5 root 2 for the hypotenuse. So we know all 3 sides of our triangle now. For the next example, I'm going to use my 45, 45, 90 pattern because I see a 45-degree angle here and we know it's a right triangle. This time I'm given the hypotenuse, the one across from the 90 degrees. So I know right away that that's 4 root 2. Well, that means that's equal to the x root 2 part of my pattern. So I really have a little equation to solve. X root 2 is equal to 4 root 2. In order to solve for x, I have to divide out the square root of 2. On both sides, they will reduce out, and I'm left with x equals 4. Therefore, each of my leg lengths have to be 4. Now, in the next example, you'll see why this little equation is very important. Here, we want to find the lengths of the missing sides, and the length of my hypotenuse is 6. Notice it does not have the square root of 2 with it. Do not put that square root of 2 down here if it's not there in the picture. So this is where the little equation is very important. We really have x root 2 part of our pattern is equal to 6. So in order to solve for x, I have to divide by root 2. Well, that means that x is equal to 6 divided by root 2. So we have to rationalize that denominator because we cannot leave that square root of 2 in the denominator. So we multiply by root 2 over root 2 and get 6 root 2 over 2, and 6 divided by 2 leaves us with 3 root 2. So each of our legs are 3 root 2. I'd like you to try this example. Notice you're given one of the sides across from the 45. So that will be one of your legs. I also want you to try this example where AB is 14. Notice AB is the hypotenuse.